We are going to continue our work from yesterday, learning about solving systems of equations using the elimination method. Sometimes, if you need to use the elimination method, you don't have coefficients that would create a zero pair. If that happens, you have to manipulate your equations so that you do have equations that create zero pairs. We do this by multiplying, and we would multiply. Sometimes you only need to multiply one of your equations, and other times you need to multiply both equations. And once you've done that, you are going to solve your system using the elimination method just like you would any other. So let's look at an example. So carrying on from yesterday, if we look at example 5, in this example we have 3x minus 2y equals 3 and negative x plus y equals 1. What I notice when I look at this is that I don't have a zero pair. This x has a coefficient of 3 and this x has a coefficient of negative 1. I also don't have a zero pair with my y's because this y has a coefficient of negative 2 and this y has a coefficient of positive 1. So if I don't have a zero pair, I have to create that zero pair. So what I'm going to do, because if I look at my second equation, both of these have coefficients of 1 or negative 1, so they're probably pretty easy to manipulate. I notice that this x has a coefficient of 3, and this x has a coefficient of negative 1. If I multiply negative 1 times 3, I'm going to get a coefficient of negative 3, and that would give me a zero pair here. So I'm going to change this system so that my first equation stays the same, so it's still 3x minus 2y equals 3, but my second equation is going to be multiplied by 3. And just like when you're adding or subtracting, when you're multiplying, you have to make sure that you multiply that 3 by every term in that equation. So it's kind of like distributing the 3 to everything in the equation. 3 times negative 1x would give me negative 3x. 3 times positive y would give me positive 3y, so I would write plus 3y. And then 3 times 1 would give me 3. Now I'm just going to focus on this system of equations. And what I've done is I've created a system that has a zero pair because positive 3 and negative 3 can be added to create 0. So that means that's what I'm going to do. I'm going to add these two equations. If I do 3x plus negative 3x, I get 0x, so they cancel. If I do negative 2y plus positive 3y, I get positive 1y, which is just y. And then equals, and I do 3 plus 3, and I get 6. So in this system of equations, I know that y is going to be equal to 6. Now I'm going to plug that in. So if I take my first equation was 3x minus 2y equals 3. If I plug in a value of 6 for y, and I can solve for x. So 3x minus 2 times y, but I'm going to say 2 times 6 equals 3. I'm going to simplify. So 3x and then negative 2 times positive 6 is negative 12, and I will write minus 12. Now I'm going to solve my equation like normal. I will add 12 on both sides. These are going to cancel and leave me with 3x equals. 3 plus 12 is 15. And then finally, I'm going to divide by 3 on both sides, and I'm going to get x equals 5 because 15 divided by 3 is 5. So the solution to this system of equations is an ordered pair where x is equal to 5 and y is equal to 6. So my solution would be written as 5, 6. Let's look at this next problem. In this next problem, I have 2x plus 5y equals 3 and 3x plus 10y equals negative 3. I notice that I don't have zero pairs because I have a coefficient of 2 and a coefficient of 3, and a coefficient of 5 and a coefficient of 10. So I asked myself, what can I do to make this so that I would have a zero pair? Well, I know that 5 is a factor of 10. And to get from 5 to 10, I would multiply by 2. But if I want to make a 0 pair, then actually I should multiply by -2 because that would give me negative 10y here. So I'm going to change my system of equations by multiplying my first equation by -2. Again, I multiply every term. So -2 times positive 2x is -4x. -2 times positive 5y is -10y, so I'll write -10y. -2 times positive 3 is -6, so I'll write equals -6. I didn't change my second equation, so I'm just going to rewrite it the way it is, which is 3x plus 10y equals -3. Now I notice that I do have a 0 pair. I have a -10y and a positive 10y. So to get those to cancel each other out, I would add those together. So I'm going to add both of these equations together. If I do -4x plus positive 3x, I get -1x or -x. -10y plus positive 10y is 0y, so they'll cancel out. And then I have my equal sign. And if I do -6 minus 3, I get -9. Now, x looks like it's by itself, but it's not because it has that negative sign there, which means there's actually a -1. So I'm going to divide by -1 on both sides. That will get rid of this, and that leaves me with x equals, and then when I do -9 divided by -1, I get positive 9. Now, I need to use this to find the value of y. So if I go back to these, I can use my first equation, and it doesn't have to be this one because these are equivalent equations. So I can use what it originally gave me, which was 2x plus 5y equals 3. And I'm going to substitute 9 in for my x. So instead of 2 times x, I'm going to say 2 times 9 plus 5y equals 3. 2 times 9 is 18, so this is 18 plus 5y equals 3. Now I need to get y by itself, so I'm going to subtract 18 from both sides. 18 minus 18 will cancel, and I'm left with positive 5y equals 3 minus 18 gives me -15. Now I'm going to divide by 5 on both sides. These are going to cancel and leave me with y equals, if I have -15 divided by positive 5, then I get -3. So the solution is going to be an ordered pair where x is 9 and y is -3. So I will write that as 9, -3. And this will be my solution. All right, for our last example, we have 4x plus 5y equals 35. And -3x plus 2y equals -9. If I notice with these, none of these have 0 pairs, but also none of them are factors of the other. So 4 is not a factor of 3, and 3 is not a factor of 4. 5 is not a factor of 2, and 2 is not a factor of 5, which means I might have to actually multiply both of these equations. So if I do that, I want to look at what do I have that I can work with? Well, in this equation, I have a coefficient of x that is positive, and this one is negative. So that means if I keep these the way they are, I would be able to add them together to get a 0 pair, but only if that coefficient had the same number. So what I'm going to do is I'm going to take my first equation, and I'm going to think, what multiples do 4 and 3 have in common? So 4 times 1 is 4, but 3 is not a factor of 4. 4 times 2 is 8, but 3 is not a factor of 8. 4 times 3 is 12, and actually 3 is also a factor of 12. So I'm going to multiply my first equation by 3. That's going to give me, so 3 times 4x will give me 12x. 3 times positive 5y will give me positive 15y. And 3 times 35 will give me 105. Now, I need my other equation to have a 0 pair with 12x. So, what can I multiply -3 by to get negative 12? Well, I'm going to take negative 3 and multiply by 4. 4 times negative 3 is negative 12x. 4 times positive 2y is positive 8y. And 4 times negative 9 is negative 36. Now, once I've done this, I finally have a system of equations that has coefficients on x that would make 0 pairs. And if you go back to what we did originally, all you really have to do is take this equation and multiply it by this number. So I would multiply it by 3 instead of the negative 3. And then I would take my second equation and multiply it by this number. So I'm multiplying it by 4. And that's where I get this. Now, I know at this point that if I add both of these together, my x's are going to cancel out. So I'm going to add my two equations. 12x plus negative 12x is 0x, so they cancel. And then 15y plus 8y gives me 23y. Then I'm going to do 105 plus negative 36, which gives me 69. Now to get y by itself, I'm going to divide by 23 on both sides. These will cancel and leave me with y equals, and when I do 69 divided by 23, I get 3. So now I just need to find out what x equals. So I'm going to go back into one of my equations, and I usually just pick the first one. So that first one was 4x plus 5y equals 35. I'm going to plug in 3 for y. So this is 4x plus 5 times y, but I'm going to say 5 times 3 equals 35. And then 5 times 3 gives me 15. So this is actually 4x plus 15 equals 35. Now I solve like normal, so I'm going to subtract 15 from both sides. These will cancel and leave me with 4x equals 35 minus 15 gives me 20. Now I'm going to divide by 4 on both sides. These are going to cancel and leave me with x equals, and 20 divided by 4 is 5. So my solution is an ordered pair where x is equal to 5 and y equals 3. So the solution is 5, 3.